So I hope, good morning. Hello, thanks, Niels.
Good morning.
I hope my screen is now available.
Yeah, it looks fine. Thank you.
Okay, so hello to all other. I want to show you our condition monitoring solution that's called Peakanalyzer, and as an online condition monitoring that integrates into the back-off control and for gearbox and main bearings analysis here. So first of all, some advantages of condition monitoring itself. You want to schedule your maintenance and decrease production downtimes to have more productivity of your wind turbine or, in fact, any other machine you want to monitor. One other point is that you can reconstruct the damage development. So if one damage occurs, you want to avoid subsequent damages, and that you can do with our condition monitoring solution. The most important point is for many operators that you also document intact drive elements. So you may shift maintenance intervals to a larger cycle when you know that there is no defect on the machine. Moreover, the integrated condition monitoring, I think Niels already stated most of the advantages, that you have reduced hardware costs since you can reuse your integrated industry PC or the embedded variant, and do not have a coupled standalone system. So you can also reuse sensors like the speed sensor or many other like wind information or the load of the machine. So this also results in a reduced space usage in the control cabinet, and you only have to maintain one system. So there's not only an installation advantage, also during the operation of the machine. So our condition monitoring system consists mainly of two methods. What we do in our system, the one is called base diagnosis. This is mainly the calculation of RMS values, especially of vibration velocity and vibration acceleration. That's according to some standards like DIN ISO 1086021 and 3. And in fact, we calculate broadband characteristic values that contains the level of vibration of the machine. So if there's high vibration, these characteristic values increases, and you can set up thresholds to get an alarm message if the vibration is too large. This is a very basic analysis since you have no detailed information on which part is involved in the increased vibration. So you don't know exactly which drive element may have a defect, which bearing is responsible for that. And that has the advantage that you have very low configuration overhead, and you can also react very fast on this value in terms of seconds. So maybe you can switch off your machine if you get too much vibrations. But you have no exact information which part was involved and what you may have to do during your maintenance. So the next method that we use is the advanced diagnosis. In fact, we do a measurement of the time signals and do a calculation of frequency and envelope spectra, as well as order and envelope order spectra. I will show some details or examples on that in And the next slide. And on these spectra, we do a frequency selective analysis and do a search of kinematic patterns that match to the specific drive elements that are in your drivetrain. So the main advantage is that it's highly reliable because it's a deterministic pattern of the specific drive elements that are in the machine, and you are able to track the damage evolution of these specific drive elements. So if a bearing has a defect, you can track that over a very long period and can schedule your maintenance cycle accordingly. A small disadvantages of this is that it took a little bit longer to get a reliable answer of the system, since we have to do a lot more calculation and evaluate this accordingly. And during the configuration, we have to enter kinematic parameters of the machine. So you need to know how many tools are on the gear and which bearings are in the machine. So some examples for that, if you have a gear and local tooth flank damage on this gear, it may look like this. You can find this specific damage in the order spectrum, that you have the tooth mesh frequency in the middle of this, and near to that you have side bands in the rotating frequency of the shaft that is on the gear. So this is just one example how we determine this this specific damage. You don't have to know how we do this exactly. You only have to enter the, in this case, the tooth number of the gear, and our system will do the rest mainly alone. Another example is the shaft damage, as you can see in the picture. This results in the according spectra that you have the rotating frequencies in the envelope order spectrum, as we can see here, for example. So these peaks are an indication that we can that we have this shaft damage. So one further example. We have this inner ring damage with this indication here, and in the recycling order spectra we have the inner ring order that is marked in the spectrum here, and in fact we see the inner ring order and its harmonics in the spectrum. And this is also an indication that the inner ring of this specific bearing is damaged. And now we have the possibility to track each individual damage over a long period. So on this inner ring damage, we can track the specific peaks over a long time, and that is shown in the next slide. So we have at the beginning an intact bearing, and now the damage arises and it increases over a long time. So this is a snapshot over 1 year, and you can now see that you have a damage and schedule your maintenance cycle and order the specific parts that you need to exchange everything. And at this point we have exchanged the bearing, and now the level for our diagnosis falls back to the low base level. So this can therefore be a very good use to monitor your whole drive and schedule everything. At the other end, we have a user interface for our components that runs on this IPC that is called Pickerelizer Manager, and provides you an interface to monitor several hundreds of Peakanalyzer and in fact the drivetrains behind that. And it's a tool where you can configure everything on our system. You have the complete alarm management in it, and it's moreover a data gateway to all systems that are connected to it. And you have very detailed analysis tools on top of that for further analysis. In fact, as I said, you don't have to know how we exactly determine the alarm. You get plain text messages of our system. So in fact, you have, like I showed you the examples, a local irregularity on a pinion or something else, and you get this exact message from our system. And now you have the possibility to dive into the data and do some more evaluation on that. So a little bit more details on the integrated system itself. We provide fully integration in the TwinCat3 environment. So in the base level, we have the terminals where you have your existing control cabinet, and you can reuse some of the I/O terminals for our system and link them directly to our driver that is on the same system. And you may also have some additional terminals that is exclusively for our condition monitoring. For example, the vibration sensors are mostly only needed for the condition monitoring and not for the control cabinet. So on this TwinCat3 system, we have a TC-Com module that can also interact with all other TC-Com modules or PLC systems that are already there. And we integrate also in this TwinCat3 engineering environment. There's plugin provided from us where you can configure this bottom parts. And on the other side, it's a Windows server on this back-off system that is in fact our Peakanalyzer software that interacts with our Pickerelizer Manager software on the other side. So just one example. I think the pictures from Niels beforehand were a little bit more representative. One more point on integration. The first one was on how I do this on the hardware basis, but we have also integration in the complete control cabinet, and also maybe in the software that the operator has already for the maintenance service. So in fact, I showed you some slides of our user interface, the Peakanalyzer Manager, but the operator can also build up completely its own user interface, and therefore we provide data interfaces like OPC UA, MQTT, or web services that you can get all the data from our system with standardized interfaces. And it's up to the end user to build up your own user interface and integrate it in your existing maintenance software, so that you have a step more into integration in existing solutions. And another point is that you can also interact with in real time to, maybe other standalone systems that are there. So you can interact via Profibus, Profinet, CAN. I think I missed one important, EtherCAT is of course also possible in this step. So a complete integration is provided for our Peakanalyzer software. So to summarize up some key points, our Peakanalyzer provides very high sampling rates based on the Beckhoff hardware, and you can also do very long measurement times that are very important for slowly rotating drives. You need a very high resolution on these parts to get qualitative good analysis. We always do an order analysis via resampling. So this is very important to compensate speed ripplings or in general variable speed machines like, in fact, every wind turbine. We have a fully automatic determination of the location of the damage, as I showed with this plain text messages you get from the configuration of the drive. We do an DVS analysis that is required for partial loads, or if you have also variable load situations, then you need to actually to compensate these different load situations. So, and in fact, at the end, we have also the standardized norms in our system, like DIN ISO 1086021. So, that was the summation of our Peakanalyzer. And thank you very much.